Hey guys, welcome back to a new video in which we'll be diving into some really important concepts in C programming that help keep our code clean, organized, and efficient. We are going to talk about header files, macros, file inclusion, and conditional file inclusion. Now I'll walk you through what each one is, why we use them, and how they work with complete examples that you can run yourself. So let's get right into it. Let's start with header files. In C programming, a header file is a file that typically contains function declarations, macros, constants, and data type definitions that you would want to use across multiple files. Now, header files make it easier to organize and reuse code, especially for larger programs. By convention, a header file has a .h extension. Now, here's how a basic header file looks like. In this, we have used several different directives and statements. Now let's begin by understanding what do these three directives mean. Now these directives are basically used in conditional inclusion. We also call them as include guards. Now what do these include guards do is they basically prevent the file from being included more than once, which can lead to errors. Here in this header file, we have also declared a function called greet, which will basically print the name of a string which will be given to it. And we have also created two macros, pi and square. Now these macros allow us to use pi as a constant and the function square as a macro function. It is called as a macro function. Now we will see this in detail. Let's begin with what are macros. Now macros are one of the most coolest things in C. Macros let us create shortcuts with the hashtag define directive. So we can substitute code in our text. Macros make it easier to write readable and reusable code. As we saw in the example above, here we have declared a constant pi. This is a macro constant, and we have also declared a function square. This is known as a macro function. Now these macros allow us to avoid repeating values. In this case, the value of pi, that is 3.14, or in the case of the macro function, rather than writing the same multiplication, that is this to get the square of a number, I can just write square provided with the value x. Now let's see how we would use them in our code. Now later in the main example, what we'll do is we'll include this header file so we can access the value of pi and square in our main program. So let's go ahead to the next concept which we need to know, which is file inclusion. Now file inclusion, basically in C, we use the hashtag include directive to add code from other files directly into our program. Now there are two types of file inclusions. The first one being standard library files, which use the angle brackets, and the user defined files, which use the double quotes. Now let's see examples on this. Now whenever we define or include a header file such as the standard input output header file, we usually use the angle brackets. Now why do we do this is because the stdio.h, that is a standard input output.h header file, belongs to this, is a standard library file. It is not a user defined library file. Okay, it is a standard library file. Whereas if we define or make our own header files, in order to include them in our code, we need to use the double quotes. So I would include them in this way: my header dot h. Okay, which we will use in our code to access the functions and macros defined in our own header files. Now, why do we use file inclusion? Basically, in order to include header files in a program. Now, as you know, header files help us organize code by splitting it across different files, and this is crucial in especially larger projects. Instead of defining everything in one file, what we can do is we can use header files to store declarations and include them wherever we need. Now let us come to conditional file inclusion. Now what is conditional file inclusion? Now let's say if a header file has already been included or defined, we shouldn't define it again. Okay, so conditional inclusion basically helps us keep a track of that or basically check that. Now conditional file inclusion basically lets us include files or parts of a file only if certain conditions are met. Now this is really useful in cases where you want to perform debugging or prevent multiple inclusions of the same file. Now we do this using the directives like the if not defined, if and also known as if and def, That is, then comes the if define and the end if. Okay, so remember the include guards which we used in our first example. We are seeing the same thing here. Now this includes guards. Guards basically check if this name is already defined. If it is defined, it does not define it again. But if it is not defined, it defines it and it includes the content of the file. Now this prevents the file from being included multiple times, which can happen in larger programs. Now let's put this all together with a complete example. So I'll go ahead and open my VS Code, and here I will create three files. Here I will create two source files and one header file. So let's go ahead and first create a simple header file. I will name it myheader.h. Now in this header file, first I will include my include guards or my conditional inclusion directives. So first what I'll do, I will check if this header has been defined or not. myheader_h. If it is not defined, what I will do is I will go ahead and define it. And inside this, I will declare my function, which will print the name or a string. Your character array means a string. Now we will be seeing this in the next lecture where we will be learning about arrays and strings. Then I will define my macro constant, which is pi. And then I will declare my macro function. I will define my macro function. This will give me the square of a number. Now wherever I mention square with a value, it will substitute it with this instruction. Okay, that is x into x. That is the square of a number. Make sure the variables are named correctly. They are not in uppercase or lowercase. It might cause issues then. And the last directive will be the end if. Okay, to signify the end of the conditional inclusion directive. Okay, this is my header file. Now I'll go ahead and create another file where I will define my function. So I will name this functions.c, and in this file I will define my function, hashtag include my header.h. I will include my header file here, and then I will include my standard input output file. Oh, just a small mistake we made here. Remember, user defined header files, we will use the double quotes to include them. Okay, and here I will define my function. Now this function will basically print the string. And the third file which I will create is for my main function, which will execute my code. Here also I will include my header file. Then I will include the standard input output file, header file. And then I'll write my main function. Here I will call the function greet, and I'll give my name. Then I will print the value of pi, which is a macro constant. It's a float value. Okay, here pi will be substituted with the value 3.14, and then I will call my macro function. Let's go ahead, compile and run this program. Now in order to compile it, I will have to compile both the source files together. Okay, to compile and link them. gcc main.c and functions.c, and I'll give my output as program. Let's go ahead and run this. So as you can see, it printed the string. Just give me a second. Yeah, It printed the string, it printed the value of pi, and it also gave me the square. Now what we will do is, just to strengthen our concepts and understand a bit more about conditional inclusion, what I will do is we will add a simple conditional inclusion example to the same program. Basically, what we will do is we'll just modify this header file to include some debug code if a debug macro is defined. Okay, so let's define a debug macro first. Define debug. Okay, now if the debug macro is defined, what we will do is we will define some debug statements or function. So in this case, what I will do is, if debug macro is defined, that is if define debug, I will include the standard input output header file. Then what I will do is I will define a function that is a print function, debug underscore print. It will print the string x, printf, debug, percentage s for string, and the string will come here. Okay. So if I have defined debug in my code, what will happen is it will include this line. Okay. This macro will be included in my program. Else what will happen is, if I have not defined the debug macro, it will just return to me an empty macro function, that is debug print. This function will not do anything, so it won't be substituted by anything. And don't forget to end it. So end if. Okay. So let's say if I want my program to be debug or have some debugging statements, I just need to define this debug macro. In case I don't want, I can just comment this out. So as you can see, the color has changed here. Basically, it highlights that which code will actually be included in my code program. So if I define the debug macro, as you can see, this code will be included in my program. And if I don't define the debug macro, the other one will be included. Okay, now let's go ahead and try to call some debug functions. So here what I will do is I'll get debug print, and I will say this is a debug message. Okay, now what will happen here is that this will only print if the debug macro is defined. Now what happens if debug is not defined? So let's try to execute this when debug is not defined. So what will happen is it won't actually execute anything because we have written it in that way. So as you can see, it hasn't given anything. But if in case we want to perform debugging, as in this example, I will just include this debug macro. I will compile my program again, and once I run it, I can see I got the debug message. Okay, so this is how we can use conditional inclusion in our programs to perform debugging. So to recap, today we covered the fundamentals of header files, macros, file inclusions, and conditional file inclusions. Now these tools allow us to write cleaner, more organized code and make it easier to manage larger programs. Now I want you to try this code on your own and let me know how it works for you. Thanks for watching, and don't forget to subscribe for more tutorials. Leave a comment if you have any questions. Till then, I'll see you in the next video.